Hello, good morning, good afternoon. Hello, everyone. And I'm Panos Stavrakakis. I'm here to welcome you to this year's SAFETY GALA and the session 7th of this very important international event. This session is titled Reaching New Heights in Safety. I'm very happy to host in this session a fantastic variety of panelists that are coming from every corner of this globe. And of course, they are Greeks, but are Greeks of diaspora, and they are experts, leading experts in their field. For the audience, for our audience, I would like to ask you to upload your questions to the chat box, and in order to, after the presentations, to follow a Q&A session. And I think it is time to start with Michela. Michela, you have 20 minutes for your presentation. And please make a brief introduction about yourself, and then you can follow with your presentation. Michela?
Hello, hi, hello everyone. Thank you very much, Panos. Okay, that was quite a surprise that I'm first, but yeah, that's all good. Yeah, good afternoon, good morning, everyone, wherever you are around the world. Very happy to be with you here today. I'm going to be sharing my screen, and I will do a very brief introduction, Panos, if you don't mind, through the presentation itself. Okay, it should be coming very soon. On full screen mode. I'm calling from London today, so it's a good morning for me. Today I'm going to talk to you about life cycle, of course, in the context of safety. So the presentation is going, of course, to cover a very brief introduction of who I am. Obviously Greek by background, but currently based in the UK. I'm going to talk about life cycle models, as I already mentioned, from a system safety perspective, and also I will try and draw the links between system safety and worker safety, or health and safety, as we know it across the world. And of course, we're going to close with some key takeaways. So introductions about myself, I will keep it very short. I'm currently working for an international consultancy called ARUP, and I'm the global research leader. So I'm responsible for all the regions, for 4 different regions from the Americas to Australasia, for all the research we do, and I lead the portfolio. Before that, I was working as a consultant, as a system safety consultant for a big consultancy called WSP, and my focus was on railway projects mainly. For those who are familiar with the railways in Europe, it was High Speed 2, connecting London to Birmingham, Crossrail, the infamous new line crossing London, the Elizabeth line as we call it, and of course the UK national highways as well, some highlights really of my career. But I'm an academic by background, really a researcher, and I'm very proud of that. I did my PhD on system safety and situational awareness, and actually I think that my supervisor is listening in today, so it's Dr. Ioannis Dokas, so many greetings to him. I worked also as a professional researcher, as a postdoctoral researcher, as we call it, at Imperial College London and University of Cambridge in similar areas. So this is the background I'm bringing today in this session, and I will be focusing on construction and the residential sector, and I will explain to you why really that's of interest to me. Speaking of which, the motivation for today's topic really, of course, there was this appetite from the organizers to hear about safety reaching new heights and, you know, life cycle approaches. But to me, it's very close to my heart because 5 years ago in London, I'm sure you're already aware of this tragic accident. We had a massive fire in the area of Kensington in London in a residential building, a high-rise residential building, which killed 72 people really and injured many more. So since then, the construction industry in the UK, but also across the world, started changing a lot and at a very fast pace. So this is what I'm going to talk about today. So the investigation report, which is still ongoing, and actually my current boss is one of the independent assessors in this investigation report, communicated several messages, but all of them had a common denominator, which I'm going to highlight very soon. So just to touch on some key points from the investigation, the main reason why this fire really broke out was the exterior cladding. There are those pretty much tiles, if you're not familiar with the word cladding, they're the tiles really that hug the building around it. So it was a combustible material, which was very prone to fire risk, and it wasn't abiding by fire and safety regulations. Since then, since the investigation report, one of the key messages was that there is an imperative need to consider construction systemically, as opposed to isolated objectives. And of course, as I just mentioned, that this shift, considering buildings as systems rather than individual subsystems that constitute eventually a building, this mentality changed the way we think in the construction sector in the UK. And as I said, not only in the UK, across the Commonwealth and beyond as well. The main product of this accident, unfortunately, it was one very important report, which I highly recommend you read if you're interested in the area, was the report, as we call it, the Hackit Report, because it was written by Dame Judith Hackit, and it's titled Building a Safety Future. And it was accompanied by the Building Safety Bill here in the UK. And the key messages that this document really communicates is that in the construction sector, and specifically when it comes to this accident, the Grenfell Tower fire accident, it was uncovered that there is much ignorance in a sense that regulations and guidance are not always read, or when they are read, they're not read by the right people or to the right extent. There is indifference. So things, as you would expect, unfortunately, are done very quickly and cheap and fast. So this is something we definitely need to change. There is lack of clarity of roles and responsibilities, and this doesn't only apply to the residential sector, but across major projects. And I'm speaking from personal experience, really, even on major projects like High Speed 2, even High Speed 1 that connected the UK to France. And of course, there is inadequate regulatory oversight or enforcement tools, really. So we have the regulations, but the investigations are not done in a process-orientated way. So the key message, as I promised to you that I'm going to share with you today, from all these different documents that emerged from the main report around Grenfell Tower, said that buildings need to be considered as systems, in a sense that up until nowadays, up until the Grenfell Tower, buildings used to be considered as boxes, which were pretty much independent from the environment, either though that was the natural environment or the built environment. But actually, the shift in the mentality in the construction sector says that actually the interface with the environment, that's why we need the systems approach, and their safety needs to be considered on the case-by-case basis, because the building exists in different environments, so that in that way we need to consider the building, how the building interfaces with a different environment it exists in. So the proposed solution in the UK was the golden thread of information. This is the terminology they use, but in practice, we're talking about exchange of information, exchange of reliable information across the systems, the building's life cycle. And this is something that the UK government are going to mandate very soon through the Building Safety Bill, and it's going to apply to high-rise buildings, which are more prone to fires, and they can cause, of course, as it was the case with Grenfell Tower, more casualties. The paradigm change, which I have been talking about and I have already alluded to, is a new holistic life cycle approach to buildings. It is accepted and acknowledged that the supply chains, when it comes to major or complex projects, is very much scattered and disintegrated, but this will definitely has to change if we want to prevent accidents like the Grenfell Tower in the near future. When we're talking about life cycles and timelines, usually we have in mind a sort of linear life cycle, like the one you see in green color on the top of your screen. But actually, when you are inspired by the systems engineering approach, when we talk about life cycles, what comes to mind really is usually the V model, as we call it, which in practice is a translation of the linear model, which you can see in yellow, but actually there are some control loops. So whatever you do in whatever stage of the cycle of the development of a building, building, it needs to feed back and make sure that there is, validation and verification, as we call it. I'm not going to tire you much with that really, but in case you're interested in reading more, please type those keywords and you can learn loads of it around it. It's a very interesting area of research. And the golden thread I just mentioned earlier actually runs across the life cycle. So we need to make sure that information from the conception of the project until pretty much the maintenance of the system in place needs to be kept somewhere safe and accessible by every duty or stakeholder across the process. And when we talk about information, actually we talk about requirements, because that's what engineers, I'm an engineer by background and I learned how to work with requirements. So to me, that's important to keep traceability of requirements across the life cycle. And what I would recommend as a systems approach to safety, it's STPA, STAMP and STPA. STAMP is the accident model, and it stands for System Theoretic Accident Model and Processes, and STPA is the hazard analysis. This has been the focus really of my career from my years as a PhD student up until now. So I use this, either the mentality or the models itself, throughout my career. And what it practically says is what danger did Hackit communicated through the report, that we need to consider everything as a system, either the system consisting of subsystems interfacing with each other or the system interfacing with its environment. And it is accompanied by a toolbox. So there is an accident analysis, which is called CAS, and I have already mentioned STPA and STAMP. So it's a set of tools you can use depending on what your focus is. In practice, it changes the paradigm. So instead of focusing on reliability and preventing failures, it focuses on control actions and enforcing those control actions in order to make sure, as I said earlier, that, for example, regulations are in place and they are abided by. It is based on the typical control loop, which I already mentioned earlier when we had the V life cycle, and we were making sure that there is validation and verification pretty much at every single step of the system development. And again, it's all about requirements. So what it generates, it's requirements across the life cycle. And here, this slide, actually, I'm not expecting you to read everything, but actually the charming thing, because to me it is charming, is that tools like STPA actually integrate very well with systems theory, and actually they give you a solution for every single step of the system development across the V life cycle. So if you're interested, I highly recommend it. And again, the golden thread, traceability. The golden thread is about traceability of information and requirements. But there is still a problem, and here now I'm going to talk as a practitioner mainly. So on all the projects I have worked on, unfortunately, there is a massive chasm between system safety, which is more about the operation of the system, and the occupational health and safety, which is the worker safety. So those are pretty much delivered by different stakeholders from the supply chain. But also, even when you deliver on a wider system safety scope, for example, different consultants deliver on different small scopes from the system safety. So there is a lack of integration, both when it comes to system safety alone, as well as when it comes to occupational health and safety. Different supply chain stakeholders deliver on different scopes. This has to change. There has to be an integration if we want to have traceability and if we want to achieve the golden thread of information as the UK government requires. And also, there is an interface between system safety and occupational health and safety. Usually when we develop plans around system safety, we exclude everything that falls within occupational health and safety because we say, oh no, that's not within our scope. But I think that's quite dangerous because we may miss some important points. And this is the main message I would like to communicate to you today. So what's the recommendation? As you probably know, BIM, Building Information Management, is a platform which can help us really create digital twins of the systems we are going to deliver in the future, monitor their behavior, their emergent properties like safety across the life cycle from the conception into the delivery and the maintenance of the project. And this is what actually I'm recommending today, that when we talk about system safety, we should actually both include the building safety, the infrastructure, the tangible infrastructure itself, but also bring together the worker safety and find the links if there are any. So there is a conceptual recommendation there, which I have actually submitted to a journal currently based on, as I said, on my hands-on experience as a consultant in the UK. And why building information management? It is a tool that can give us accuracy, which is very important. It can give us reliable information that is accessible by everyone across the life cycle. And also it's about integrity. It's not only about safety, it's about integrity, as I highlighted. So BEAM seems to be a good way to materialize the golden thread of information. And as I said, it's going to be a mandate by the UK government. So BEAM seems to be the most reliable solution that we have for the time being. So some conclusions really to wrap up today's presentation. Buildings are definitely complex systems. So we need to forget this approach that, oh, they are boxes we just build somewhere and they are there forever. Safety is a systems property from a systems engineering perspective, and therefore it emerges. So we can't identify it in a single component, but it emerges from the interfaces and interactions between components. Systems thinking is and the corresponding tools can help us manage safety, as I said, STPA, and there are also other approaches like FRAM, for example, can help us deal with complex systems that are prone to safety risks. We need to manage safety through requirements. This is what we understand in industry. We can't understand highly intellectual, really, theories. It's all about requirements. So anything that can generate requirements and can also track and trace requirements is what really we need to see more. The golden thread, as I said already, can materialize into BEAM. And I believe that although I have been focusing today on the UK, this is going to be very soon a case across the world, really. And the golden thread can help bring building safety and worker safety together, as I said, and make sure we don't lose any safety aspects, really, because at the end of the day, it's all about safety. Both of them are different perceptions on safety, and they have to be considered as one. And last but not least, I focus today on residential buildings and construction and the cases of fire, but we have seen Notre Dame fire was pretty much prone to the same safety risks. The Miami collapse, which we saw, I think it was last summer or the summer before, I'm sorry, with COVID, I lost the sense of time, really. But all these approaches can be applied really across different applications in the construction sector. So yeah, thank you very much. I hope I kept on time and I didn't make Panos your life difficult. So thank you very much. Panos, you're on mute, I think. Yep.
Yes, okay. Thanks, Michaela. You are on time. Thank you very much for this very, very important presentation. Thank you very much. And it was really impressive, very informative. I'd just like to add that the Grenfell event, the incident, gave birth to a new regulatory regime in the UK. It is the Building Safety Regulator, which is developed by the HSE, the Health and Safety Regulator in the UK, and it's the place that I work. Of course, I'm not involved with this new regulatory scheme, but there are many changes in HSE happening due to this regulatory scheme that is adopted and developed by HSE. I think now it's time to move on to our next panelist. It is Nektarius Karanicas, Professor Nektarius Karanicas. I'm very happy that we are having here Nektarius. Nektarius used to be an ex-colleague from the Hellenic Armed Forces, from the Hellenic Air Force. He's also an engineer, and he's now an academic, a very reputable academic, and he's coming now from the very beautiful Queensland in Brisbane in Australia. Nektarius.
Hello, everyone. Thank you very much, Panos, for the introduction and for the invitation and organizing this session. I will start with sharing my screen to be ready to go. I hope you can see that. Yes. So good evening from Brisbane, Australia. Nektarius Karanicas. I am currently at the Queensland University of Technology. I've been in Australia for about 3 years. Before that, I was an associate professor in aviation safety and human factors back in the Netherlands in the Amsterdam University of Applied Sciences. And as you may be understand, I did quite a shift from system safety, as Michaela said before, to occupational health and safety, and it's another world. Before that, I was in the Greek Air Force for about 90 years as an officer, aeronautical engineer by trade, but I studied my master's in health, in human factors and safety assessment, and then my doctorate in safety and quality management. So my presentation today, it's a bit less technical than Michela's presentation, but it matches very well what Michela touched upon, which was about those interfaces, this mindset about systems and systems thinking. And I will start with a quote from a very excellent colleague from Ireland, Mrs. Marian Keeley, who wrote a chapter for a book that Michelle and I co-edited about 2 years ago now, with excellent, nice accounts, stories, confessions actually from professionals from the field. And Marian nicely stated that we should not just rush to action when we have a problem, when we have a challenge, when we think we need to do improvement. We should sense, we should listen, we should watch, we should have our radar open and try not to lose the bigger picture by looking at the very detail of a system. So based on that, I will also start with some definitions. And sometimes we don't give to the definitions the attention they deserve. Although science suggests that definitions drive our thinking, drive our actions, consciously or subconsciously. So I have 3 definitions that I came with while contemplating what is health, what is system health, and what is safety. And I must confess and admit that I change these definitions every time I have to present. Every time I have to give a lecture, I go back, I consider what I learned, what I read, what I experienced during my professional and academic life, and I say, does it make sense? So I don't want you to accept the definitions. I just want you to pay attention to the same word repeated across those definitions. And this is about interactions. And this is the core of the thinking when it comes to safety within systems or safety about systems. So I don't know if you have the opportunity to watch this slide again. I don't want to stick with the definitions themselves. I just want to highlight that for me, as Michela nicely stated, everything it's about how elements interact and what those interactions produce. And safety can have different labels. Some of them, some of us label safety as an outcome, as a product, somebody as an objective, something to achieve. Some others as a characteristic, as a property, as a feature, as a state. We are all wrong and all right at the same time, because it's a matter of how we approach safety, how we see it. Nevertheless, we must not forget that safety is an immaterial construct. It's not something we can touch. It's not something that we can directly manage or control. It's not anything that you can measure, that you can see. It's something that represents those contributions and those interactions within a system. Now, the challenge within systems is that we don't have health and safety alone. The system tries to do many things at the same time. So the interactions between different system elements might conflict, and there might be circumstances where even the system health and individual health are incompatible because we have not designed them as such. I mean, we might have designed a great system to produce whatever we want, but not caring for the worker. Or we might care for the worker and then forget how the system behaves and what it generates. And we should not forget, when we're talking about systems, that we have so many processes and activities And if we don't design those activities with compatibility, so they can be friends, they can go, you know, hand in hand, in tandem, and not conflict, they will clash, because all those activities consume from the same pool of resources. And one of the challenges I met in my professional industry life is that we're so perfectionist about our fields, about the quality manager about quality, the production planner and manager about productivity, the safety manager about safety, and we do so great things, but each of them can seem excellent in the design, but when you put all those perfect things to work together, they cannot, because they clash, because we don't have infinite resources and capacity to the system to do everything in parallel and to satisfy everything, you know, in its maximum. We cannot optimize everything. And Rasmussen actually, decades ago, not recently, presented this model of risk management in dynamic systems, a dynamic society, and illustrated how the tensions from management, who wants more efficiency, wants also more market competitiveness based on great quality and other features, can push the boundaries. At the same time, the workforce, as humans who we don't like to get tired, we want to have a, you know, a pleasant work environment in the way we perceive that, and get back home without not being, let's say, exhausted, which is our right. And this is how we have evolved our societies in our era. But sometimes we push too much there. So when management pushes and workers also push, then what happens that we end up on the left of this nice graph? Do we harm safety? Actually, we diminish any margin that we have in the systems about safety. And those things happen slowly. We don't drift into failure just in 1 second. Those problems, as those tensions, incubate within systems. And I will quote another friend that did the honor to write a chapter for our book, who greatly expresses his opinion that we need to consider everything in a balanced way. That's another great message. So let's go a bit deeper to the systems. So when we're talking about health and safety, we talk about those stakeholders, the key players, the workers, unions, employers, governments, regulators, insurers, we should not forget this, this part, and the profession of health and safety. But when we are talking about the organizational system, we cannot neglect that the system does not exist in isolation. It exists within a bigger reality with specific politics, economical conditions, legal obligations, social expectations, technological advancements, and so on. So we have things that we have within the system, and we think we can coordinate, but we have also external factors that can play a role. And if we go a bit deeper into the internal system, I guess we can all agree that risk is inherent. There is no state of zero risk in life, not just at the workplace. And that people within organizations have different needs and objectives sometimes. Although we want to believe that we're completely and aligned and we have the same vision and the same strategy, this is a nice motherhood statement to make, but it's not very real. Each of us brings into the organization some personal needs, some personal expectations. The problem is that occasionally those needs and expectations can clash. And the question is, who's going to win, whose needs and objectives. But this is not about who's going to win. This is about how we achieve a balanced outcome, as we covered before. And how we do that? We do that by considering that a well-functioning system, it doesn't have only technical aspects, processes, hardware, software, rules, procedures, people. It needs commitment from everyone. It needs consultation, genuine conversations between all levels of organization, and needs a shared culture. We'll still have difference. We'll still have different objectives and needs, but we can still agree and on a basis that we can all work together. And another author, Connor from Ireland, also highlighted that in one of his chapters, that whatever system you have, and when you talk about safety, whatever safety, system safety, fire safety, process safety, health and safety, if it doesn't make sense to people what we say, then the system will probably fail or will not function the way we envisage it will. And what is a system? That's another misperception. We think that we have things together and we have a system. No, if those components within a specific space and time do not interact in a coordinated way with a common purpose, we don't have a system. So that's the first question. Do we have a system? Or do we have just a network of the interconnected things? Or do we just have groups that they interact, but they don't really have a common purpose? And as Michaela covered also, systems have emergent properties, things that do not exist if the elements do not interact. You can have two persons who are excellent professionals and deliver wonderful results. You put them to work together and they cannot deliver. Because this is an example, a very simple example of an emergent property of systems. And when we're talking about systems and then we are focusing on the components, we lose sight of the system, as we saw before through the quote of Marion. And last but not least, systems do not have linearity. We cannot have deterministic effects. We cannot expect that every time in every situation, A will cause B. If I do B, I will take C. This is true under specific conditions, but not always within dynamic environments. And this is just an example of how this systems approach in health and safety can be combined. That's an example of the definition we recently gave into the Occupational Health and Safety Management Systems chapter of the Australian Institute of Health and Safety. And the key points here is tangible and intangible elements, things that you can touch, hardware, things that you cannot touch, like how we share, how we communicate, how we think, which have variability, but interact under coordination and have a common purpose to promote and protect individual and system health. And we must not forget that we are part of the system and we shape the system as the system affects us. I have posed a question to some webinars, what is your system? And some of them say it's an approach. Some of them say it's a tool. Some of them think it's a document because they have a documented, manual of the system. And this is the hugest misperception that can happen to us. We see the system as something external to us, and we don't see this, that we are part of the system. We are responsible for the system as others are co-responsible with us, together with us. And another question when I presented this graph, which has different activities and processes, occupational health and safety management system, I asked the webinar participants, which one is the most critical safety management system element? And we have different answers: risk management, communication, somebody would say training, somebody else would say investigations. And those are great answers, but again miss what systems are about. First of all, if you have an element, an activity, a process in your system that works more or less than the other, so you don't have a well-functioning system, because systems have functional interdependencies. If you have something you don't need, then why do you have it? And the second and most important thing is that nobody mentioned humans. Everyone forgot to say the most critical element in any system, and it's not only about safety, it's the human, and not just one. We're talking about the whole workforce population, from the frontline worker up to senior management. We are the system. We implement a system. We interact with others, and we save the system. Please do not forget that. So the last 2-3 minutes of my presentation would like just to present to you two different, let's say, constituents of systems approach, what we name system approach, and how we can make the systems function better. One is the systematic management, which with which we're familiar, most of us. Meaning that we have processes, rules, procedures. We try to align everything and to minimize any variability, to command and control, in a few words. And on the other hand, we have systems thinking, where we say, you know, we have relationships here, we have dependencies, we cannot predict everything. That human must be the center of a system, not the procedure. The procedures do not, the humans do not serve the procedures. The procedures should serve the humans. And there are, of course, different advantages and disadvantages in those approaches. The advantages of a systematic management is rigidity. We plan, do, check out. We have the rigid processes, and everyone does the same under the same conditions. But on the other hand, they might lead to oversimplification. We overemphasize the rules and procedures. We don't give space and room to breathe. And we try to fix here and there the broken elements of systems because we think that they're not reliable and they threaten the system. Whereas what actually we miss is systems thinking. To understand that people interact with other individuals, with technology, with the environment. And we cannot control all those interactions. You cannot prescribe life. You cannot put life on a paper or 1,000 pages. We need to consider the context inside and outside the organization, to integrate instead of decompose. Is it challenging? It is, because human performance is variable. I'm not the same person every minute, every hour, every day, every week. We cannot, of course, just let people becoming chaotic. Like, okay, we don't have systems thinking, let's do whatever, you know, each of us want to do, then we lead the system into catastrophe. And we cannot just passively accept this chaos. So the interesting thing, I will skip this slide, is to find the cross-section between how much we want to control within a system and how much variability we can accept within a system. There are advantages from this combination. There is no recipe and algorithm I can give to you. It's more about a mindset and an approach to systems approach. And we have both processes and adaptation to environment and the processes. We see the system as a system and not just the components. We are more proactive through design, system design, Michaela said in her presentation and their challenges. It's difficult to balance things. We need to accommodate the modern systems with gig economy, precarious, work relationships. Sometimes the regulators, I don't know if somebody listens here as a regulator, tries to instigate this command and control into organizations, and management might not be very happy to lose power. So I have only 1 minute left. Those are common denominators in systems. I am sure that each one of you will agree about leadership commitment, support, resources, empowerment, appreciation, involvement, engagement, communication, interaction, and feedback. And my last actually slide is just a plea that maybe it's time to leave behind dichotomies and gaps that were introduced, and they served the purpose a few years ago about work as imagined and work as done. And maybe we'd like to move to this, to more reconciliation and a convergence about work as agreed and work as possible. Thank you very much.
Thank you, Nektarius, for your presentation. You give us a lot of food for thought. I would like to ask our audience to upload their questions for Nektarius and our speakers to the chat. And now it's time to move on to our next speaker, Georgios. Georgios is the heart and mind of this event, the Safety Gala. And I'm very happy to have Georgios in this session. Georgios, the floor is yours.
Thank you, Panos. But if the system doesn't need the component, so we have to leave it out. And I feel this afternoon that is this kind lady and this nobleman offered us so much, so enormous amount of information, new things, food for thought, as you said. So really, I don't know what to say. And I recall what Lucky Luke, you remember, some of you, this comic, the Lucky Luke ending the story with the saying, I'm a lonely and poor cowboy. So I feel like I'm a poor and lonely safety engineer now from the fields, and try to see, well, what to add to that. Probably they have said everything. Anyway, for the purposes of the system to run our session, I will share with you my presentation. I hope I will manage. Okay. And does this work? Do you see my screen? Panos, you named it. All right, thank you. So it's here some ideas or some experience, I would say, after 33 years in safety, with a background of civil engineering and doctorate in the economics of safety in construction. I am very convinced that we're still facing the same challenges and we still make the same mistakes, maybe in another level or of another magnitude or under different circumstances. Suppose that the objective, if we think sustainability, sustainable development, is to build up a beautiful world, a nice world, a happy world. But how a happy world can be happy if it's not safe? And you remember that old saying, oh, in our company, we take care of our people and we want everyone to go home safely. Is that enough? So no, it's not enough, because our company as a designers company, so we came to work safely, we design safely, we work safely, we went home, but what we built up is an unsafe playground. We came to our company, we work safely, all right, we had an accident, we killed a young boy, but myself, I'm safe. So it's not that simple, especially I received some instructions from the technical department here, that I had to make some adjustments in order for you also to see how it goes, because, well, probably I made a mistake. So it's not, so that was before the happy, the nice world that's now. So everybody should be safe, whatever we do. So towards this objective, under the umbrella of Sustainable Development Goals of the United Nations, so we construct what we design. Suppose that we follow the design, and we will operate exactly what we construct. Suppose that we didn't make any major changes during the construction, but again, through the management of change, this would go back to designers, and so on and so forth. And at the end of the day, what we have a level or a kind or a type of safety with its qualities and properties that has been decided when at the design phase. So we have to live with this. The construction then will inherit the constructability risks and problems that we have decided at the design and planning. We can give here thousands of examples. And the operation then and maintenance will inherit the risks and problems associated with the design as this has been built up. And later phases and so on and so forth, as to the end of the project life cycle of the project. So from what Michele and Nektarius explained before, presented before, it's obvious that now safety is not an engineer's job. It requires many disciplines to be involved, and not only in the systems area or the technological area, but also in terms of soft skills. So it comes more and more complicated. Now, whatever we call it, safety in design in Australia, Nektarius, or safety through design or CDMs in UK and the States, or health and safety coordination during the design phase in the European Union, it doesn't matter. We have to do this work holistically. We're talking about green construction, sustainable construction, resilience construction, and continuity of the business. And this is versus cost. And I remember that third slide, Michele showed us and said, well, try to do everything quickly and cheaply. So again, it doesn't mean, having said all of this, that it's easy to do it. Definitely not. And even if we use all the available international good practice available, again, going to the systems as explained by Nektarius, we understand how complicated it comes. And in many cases, what we designed is outdated at the time it comes to the construction. You see, these roads are packed, congested fully. So what have we designed then? What was our plan? Let's make it more, interesting. So we see a building that tipped on for various reasons. What were these reasons? When they started, you see the source, you can jump on and see more information about this report. I built in Shanghai. So they said, look, we think that we took the excavation material and put it the one side of the building, and then we keep digging the other side of the building, and then it was a heavy rainfall, and that was the reason. And they come somehow to a conclusion that it was the constructor problem. Well, definitely it's constructor's problem, or fault, but designers could have prevented this apparently, because they should think if you have a building and you make an excavation, lateral forces will be there. So and again, you have all these excavating materials. So you have a planning for the work to do. Where you get this excavating materials? Do you have a place to dispose? Do you have to dispose somewhere else? Do you have to transport them? So what is the impact on the time schedule and all this? So finally, it's clear that at the design phase, you can pick up most of the issues to face during the construction and during the operation and maintenance and later phases of a project. There are many examples around the world, like a building. All this is published, the source is there, so you can, well, from this source, you can get more examples as that, like a roof of a stadium which collapsed after a heavy wind and rainfall, or that they put a building, a high-rise building on top of a cemetery, or because of the changing of the microclimate around the building, even the body of the cars was melted. Amazing. But all these are things that you can consider during the design phase. Definitely, because thinking always sustainably and holistically, you start at the concept design and say, all right, my policies, the purpose, performance specifications, planning, funding, design basis, technology. You can decide this and to know what I'm going to do. And then at the basic design, you can have more details about what you are going to design and start identifying the hazards and assessing the risks. And you come to the detailed design, and suppose that this detailed design with some minor changes would be the build up, the as-built case. So you've got everything there. And from very early stage, you have to involve the operators, those they want this plant, this building, or whatever it is, this project to operate. Because they give the specifications, they should know about the problems, they know about their systems. But I found, well, very, very naive that we try to delay to put on board the operators in a project to save some money. And they come almost, well, I would say in the middle of the commissioning phase, not even before that. Well, what can you change when you enter the commission phase or the trial period? It's very, I would say, very naive. Let me put it like this. And you can find a lot of expressions in the very well from the English perspective in the presentation of Nektarius, I believe, because he analyzed so good the systems. And then, all right, I have the operation, the use of for purpose or repurposing or demolition or whatever it is, you have your systems. But, well, how easy now to go and change a building, a high-rise building, that I use materials, they create sun reflection, and this is an obstruction on the road to the drivers. What can I do for that? How much would cost? when it's ready. So from conception starting and going through the design and construction, well, from the very early, I have to think about the whole project life cycle. And coming to the systems, I like what Berwick says, that every system is producing the results it is designed for. The premise being that both the intended and unintended consequences are designed into our systems. It's exactly what a friend of mine says, life is very fair. You get what you deserve. When we say, no, it's not, it's because we forget all of these intended and unintended consequences that are designed into our lives. So just to sum up and say, what went wrong? Well, I was very tempted, Michaela, to take your slide and put it here, I have to say. I did it and I said, all right, I will make just a reference to that. So, but it was when Nektarius also make reference to this in his way. And so I said, all right, I stick with my slide, and then they can combine the three presentations. So we have an honest organization and project requirements. It's not matching. We want something we cannot think. We thought that because we found a way to get the money, we can build up something that is beyond our capacity. And our wishes is beyond our feasibility. We all came across a situation that we started with the concept of a project, and then we said, let's make it a little bit bigger, and then let's do a change, and then let's expand this side. And at the end of the day, we spend money, and really we don't know what we get at the end of the day. Late introduction of the operator, a big mistake. So you ask me to come and get the project like is pret-a-porter. Go to the shop. Oh, that's a very nice rope. I take it. No, it's not this. Michaela explained how complicated it is. Insufficient capacity of designers or constructors, because if we take the cheap ones, will be insufficient. So our selection criteria should include all these controls to make sure that this designer and this constructor are sufficient for the work to do. Weak coordination with the external world. So we came across situation that we have other elevation system, reference system for the project, and another one outside the project. So all the workers came into our projects, or different coordination, this part of the site, different coordination system, the other one, and then the road doesn't meet either sides. So weak internal coordination within the project, as we said, is so multidisciplinary. You need all. And here you may say, right, and why are you so much concerned about other things like time schedule, planning? Yes, I am. Because if you change the plan or if you are delayed, what will you do? A recovery plan. So you are telling me to do more work in a shorter time. That increases the risks by definition. Simultaneous operation, apparently. Or I start a project. Well, if it's a motorway, it doesn't matter. You close a part, you go one side, the other side, you can do it. But if you have a residential building, a mall, or any commercial building, and you find some antiquities, and you have to close an area, and this area represents the 50% of your laydown area. All right, tell me why you put your materials, why you put your equipment. You don't have space for that. And conflicting interests of stakeholders. That's very important. And finally, the business, costing, financing, return of investments, because we said before, we need designers and constructors of sufficient capacity. But again, our models should be developed from people, from experts, from professionals with sufficient capacity. Otherwise, we start something which doesn't work, doesn't make the money. Once you identify that this will not make your money, you try to save money, and this will be saved also from the safety, holistically approach of your project. That's what I came across in these years. And I believe it's the 7 key issues, or if you like, following a little bit the Pareto law, perhaps, okay, this represents the 80, 90, 95%, and some other 100 bridges, the other 5, 10, 15%. Well, stay definitely sustainable, think holistically. I think is very much talked about this yesterday also in the first session, so I skip this. All this about safety. So what we say in management force is that safety is an element of civilization, because we take care of the others, we take care of the resources. Resources are not unlimited, whatever these are. And we respect people, we respect health, we respect safety. Holistically approach is not just to have an accident, but be mentally well, psychologically well, sociological well. So that's from my side. Panos, thank you very much.
Thank you, Georgios, for your presentation. And I would like to thank all of you, the 3 of you, for your presentations. And I think it's time to move on to the discussion. So we have a few questions, and I would like to ask the audience to upload your questions to the chat room. So let's start with the first question, which is for Nektarius. Nektarius, do you believe that systems thinking could be embedded in an ISO system, e.g. 4001?
Great question. And we had the same question a few months ago with students here at KUT, and we did a study and we analyzed ISO 45001 against those systems thinking tenets, which I didn't have time to present. I skipped this slide because I was running out of time. So the good news is that this new international standard gets closer to what we say systems thinking. So it has elements and recognizes, interactions, the context, the workforce participation, and many other things. But what we also identified is that it focused very much internally. It's about us, it's about the organization that implements the ISO, and implicitly views external players and stakeholders more as constraints, as threats, and not opportunities. Whereas in systems thinking, something that is different from what we expect can be also an opportunity. It's not a negative by default. The other aspect we identified is that the standard still promotes a very systematic approach, like everything aligned in order, prescribed, cause effect, a bit more deterministic than what we expected, and does not acknowledge these local adjustments, the variability that things, yes, sometimes do not go according to the design. So those are the big areas we actually revealed through this analysis. Whoever is interested in this paper, please email me, send me a message, and I'm very happy to share with you our study. Thank you.
Thank you, Nektarius. The next question is for Georgios. The involvement of the final user in the design of a project probably depends on the industry. In the oil and gas sector, front-end engineering design, that is before the basic design, is reviewed by process and operations engineers. So would you consider adding poor corporate governance to the list of 7 challenges? Make them 8? George, would you like to comment on this?
Thank you, Panos. Thank you, Asterios. Yes, I know you're very sensitive about oil and gas industry, definitely. And things there are much better than, say, in commercial buildings. But again, I can recall cases having a hazard study with a client and struggling to get all the people, all the disciplines for the hazard workshop. I was very impressed. I would expect that the oil and gas, well, I believe that oil and gas is leading safety amongst the industries. But again, even in oil and gas, I came across cases that, well, is not what we want to be.
Okay, thanks, Georgios. I have a question for all of you, for your panels. I would like to consider the buildings as a workplace. I'm dealing with occupational health, so this is my major concern about occupational health. Just to mention that last year in the UK we had 145 fatalities at the workplace, while the same year we had more than 12,000 deaths attributed to occupational lung diseases. So, and also considering that the buildings are during their full life cycle, during the construction, the operation, repurposing probably, and decommissioning, are highly related with 2 major occupational risks. As I can say, it's mass killers. Apologies for this extreme term, but the statistics, it's the statistics. I'm talking about the dust that I'm putting for the COVID. The dust can be the silica, can be the new composites materials that are introduced to the construction, the buildings technology, but also the asbestos. And this is a very prevalent risks that, and also the COVID. The COVID is related with the ventilation of the building, of the layout, of the arrangements, how the building is has a natural aeration and so on. So I was considering if in the system's safety or during the design phase or introducing the health and safety by design concept in the buildings technology, I was considering if the systems fitting the system safety can be associated with these 2 major risks and make the buildings safer environments, not just for the workers but also for the occupants. So I would like to start with Michela. Michela, what is your view about this?
Thank you, Panos. I mean, that's a wonderful example really of what I have been talking about earlier, because us as safety engineers, really, when we work with a client, for example, because obviously consultants don't have any assets, we work really for our clients. And I will link back to what actually Georgios was saying. We make a mistake when we define the end user, or actually when we focus on whoever is going to receive that kind of product we produce for them as consultant. That is usually the client. It's never the end user, unfortunately. And that's a shift in mind I would like to see, because by taking into account the end user, which is going to be actually the occupant, and this obviously is very important for residential, but also for commercial and other sort of buildings. So by changing our focus, I think we consider occupational health and safety, but also not the worker safety, but the end user safety. We consider it within the system safety, the entire system safety. And it's also very important to note that specifically in the UK, and I'm sure it's the case with other countries as well, now that there is much push around sustainability, there is much retrofitting of our buildings. So when we create a new building, actually, we don't take into account how the building will look like and what sort of repurposing the building we need in 50 years time in order to be more sustainable, or we change its usage really. And this technical solution actually is going to backfire on the end user. So this is the kind of thinking we need to do. And when I talk about systems engineering or systems thinking, I'm talking about this entire life cycle approach. So this is what I highly recommend.
Thank you, Michaela. Nektarius?
You know, the problem with dust silica, it's not only a UK problem, it's a global problem. And we don't understand that what you measure today, Panos, started decades ago. So what you get as a health problem, silicosis, a problem with the lungs, people die. It's a progressive disease that kills people. Once you are affected, you will never actually recover. It's not what you do today as an agency or any regulator. We now receive the results from ignorance or lack of knowledge or underestimation of health hazards 20 years ago. That's a big problem with every health hazard. We see safety hazards easy. Falls, trips, slips, protruding, avoid. See and avoid. Big, good. When it comes to health, because we don't see the hazard, we don't smell, we don't taste, we don't see the effects, it's the huge problem. And actually, the World Health Organization estimates that more than 20 million people a year suffer from health-related diseases. And we cannot link always the disease we have with our occupation. We cannot think that 20 years, 15 years ago, we were exposed to a chemical that affects us today, whereas we change the career path. So that's the first challenge. The second is I will take opportunity from what Mr. Panopoulos said. If you want to choose the cheapest contractor, you choose the cheapest level of safety. We have the technology today. We have the ways today to deal with silica, but it's a bit more expensive than it used to be. And if you want to say about design examples, having dusty areas in one location and not all around the building, but in order to have you can also have a ventilation systems, to have those, to design the chutes, to have also wear-resistant rubber lining inside the chutes, to have wet processes, to have pneumatic transport systems, conveyor belts with cleaning devices on the conveyor belt. So I don't want to list all controls that we already know, but it always comes back to, gets back actually to cost and time and the capacity and the will. And, you know, as citizens, Panayotis, are we ready to invest in safety by buying from a more expensive contractor, or do we ourselves chase for the cheapest and we push the boundaries of the system as part of the system and crush the safety margins? Thank you for the question.
Thank you, Nektarius. Thank you. And as we say in my village in Greece, northern Greece, the the cheap option finally gets the expensive option. So,
But for whom? Not for
Yeah.
you. For me, that the worker, that's a problem now. And the society, of course, the burden on the healthcare system. But we don't see the humans as humans, Panos. We see them as numbers. How many died? What do you mean how many died? The families, the friends, the society, the skills, the experience, the innovation we lose.
Yeah, that's right. The cost in the society and the communities. This is the final cost. Georgios?
Well, I would like to show you a picture, a slide, if I may, because I buy in what Nektarius said. Are we willing to pay for the safety? So what I show you here is what the students see me lecturing at Democritus University or the National Technical University. So do you see the slide?
Yes.
Right. So we've got somebody who paid something around 150, 200,000 euros, and now is renovating the summer house. So paid about 200,000 for a summer house, but is not willing to pay for people to work safely. You see that? We go to very, very basics, right? Now coming to the health issues, right, Nektarius, how to link them. It's a big issue. Now with COVID, we know, or they try to find out how COVID attacks in a very different ways, different people, people in the same family. One is contracted, the other one is not contracted. Apparently, for what we know, yes, Michaela, you put it right. Put it under the umbrella of sustainability. Yes, then we have to pay. But it was a slide. I remember, let me get that one quickly, if I can. No, it's not here. Forget it. So, and Michaela said, is the level of enforcement. Yes, we're not willing to do that because at least let's agree on what we know. Let's agree on what level of safety we want. How much does this cost and to whom? And that's it. But we don't know that. We're very hypocritical in many, many cases, I'm afraid, and I've got to say.
Yeah, thanks, Georgios. Thanks. Just to make a comment for following Nektarius' comment. Nektarius is a very popular academic in my lab, the HSC Science Research Lab, because of his paper in occupational health in the wind industry, but also how Nektarius is approaching occupational health. So this is quite rare, and Nektarius this is highly appreciated with my colleagues with the health group in the HSC lab. So another comment for the building industry, for the construction industry, it's one of the riskiest industries in the UK. But the same time, I've seen that very few stakeholders are investing in the safety culture of this industry, while in other industries, in high reliability industries, are investing heavily in the improvements in safety culture. Even in the UK, we've seen very few stakeholders investing in this fundamental principle, the safety culture. I work with various private stakeholders in the UK, and this is surprisingly how few stakeholders are investing in this this because safety culture is fundamental. It's a fundamental principle to start making improvements in health and safety. And I'm staying for the health and safety because health and safety has a big impact to people's lives, to workers, to their families, but also to their communities. So I think it's a pledge to the industry to reconsider and make improvements to safety culture, to invest in this, and this is a business driver that can give high return on investment. And with this comment, I would like to close this session. I would like to thank our panelists, our exceptional panelists, and I would like to thank the audience for the active participants. And George, the floor is yours for the closing remark.
Yeah, I'm very pleased. That session was a very unique to me because the Michaela and Nektarius presented fantastically, and I learned a lot. I have to say that, and I will use a lot of what you presented, and I steal some of your ideas. I have, well, I confess.
Thank you very much. And
thank you all. Thank you, Panos.
Thank you, everyone.
Thank you, everyone.
Thank you, everyone.
Good night from Australia.
If there is a last thing to say is that you are one of the reasons I believe we have attracted, well, the event has attracted, because it's the speakers who attracted, it's not the event itself. People from over 55 countries around the world.
Wow.
Which is enormous, beyond our expectations. Congratulations. Thank you very much.
Well done.
Thank you.
Well done, everyone.
Thank you, Michaela. Thank you, Nektarius.
Thank you.